Now there is another part of it, like we have discussed about this electron gun briefly. Now we will discuss about this radio frequency source. So this radio frequency source or RF power generation system is very important because it is the thing which is used to accelerate the electron. The RF wave that is being generated is the one which is used to accelerate the electrons. So there are usually two commonly RF power sources. One is called magnetron, the other is called klystron. We will discuss about both of them. So either magnetron or klystron are used. So magnetron is a vacuum tube generating microwave power, and klystron is used to amplify that RF wave. So this is how it is done. So we will discuss about the physics of klystron and magnetron in detail, not very high detail, briefly. So now this is a magnetron design that you can see. In physics, you might have read about the LC oscillator. If you connect an inductor to a capacitor and if you send a voltage across it, what will happen? The capacitor will create an electric field because of it. So that AC current will oscillate, and that you see, like an inductor is just a coil of wire and a capacity by non-conducting rails. So if these are very close, they can form an electric field between these two metal plates, and this coiled wire can create an electric field in the system. So this is the basic principles of magnetron. So, and now suppose you also might have also heard about the induction, electromagnetic induction. So when you place another coil nearby, the oscillation in this coil will be transferred to the other coil using electromagnetic induction, right? Because of the changing magnetic field, you will induce a current on the second oscillator, and then that oscillator, that LC, that inductor can now generate RF wave because of the oscillating electromagnetic field. So, but in this simple arrangement, there will be a huge energy loss, and you will not be able to sustain this for long. So that is why a clever physicists have developed this magnetron. So in this system, what happens is, like, the central part is charged negatively, the same as the cathode ray, that electron injector that we have seen. So this is charged negatively and it is heated. So again, the electrons come out from it using thermoionic emission, the same physics that we talked about the thermoionic emission. So now the electrons are thrown out from this, and this side, this thing around it, this disk around it, is positively charged as compared to the centrally negatively charged rod. So what happens, these electrons then kinds of boils off, and then they run to this outer disk. But interestingly, they have kept a magnetic field. The magnetic field is shown in blue here. So you can see a magnetic field which is perpendicular to this disk exerts a Lorentz force. Lorentz force is usually perpendicular to the magnetic field and also perpendicular to the directions of electrons. So you get a centripetal acceleration force for the electrons, and the electron curve in a circular path. So this is the path. This red line shows the path of the electron that it takes. Interestingly, when the electron takes this path, it just kisses this part of this cavities. So what happens? The electrons kinds of repel an electrons here, like in the metal, and those electron then transfers to the other side because of this repulsion, and this becomes slightly negative and this becomes slightly positive. So you introduce a capacitance in the circuit without putting a metal sheet here. So this cavity acts as a capacitor. Now this small thing that you see here, this small cavity now acts as a capacitor because of the induction of this electric field. The electrons, when they come here, they repel this part, and these electrons then, because this is a metallic conductor, so this electron travel around the cavity to the other part, and this becomes like one side becomes negative, the other side becomes positive, and you introduce a net capacitance here. And during that movement, again, this outer part now acts as an inductor. So this part acts as an inductor, and here you have a capacitor. So this is how, and when you have sufficient number of electrons, this is a kind of coupling of LC oscillator. So the same thing, which is like a diagrammatical design like this, but a complex design like this, works as a RF generator. Now, when you attach an antenna to it, like this antenna, output antenna, this entire thing, when the electrons are oscillating inside, they oscillate here, there, like you can take a simile of a swing. So when someone swings, he also throws air around. So that is a mechanical swing. Here it is an electromagnetic swing. So electrons are electromagnetically swinging. So that swing is translated into electromagnetic radiation. So that electromagnetic radiation is the RF wave that we can use to accelerate our electrons. So this is the basic design of a magnetron. You can see this acts as an inductor and this acts as a capacitor. There are obviously several other complicated engineering things attached to it, like these cooling fins, because obviously when electrons are involved, a lot of heat is produced, right? Actually, your microwave oven has this magnetron, a small magnetron inside, and you see how microwave oven can heat things up very quickly. So these heat and other things are now dissipated in this case. Klystron is a slightly different concept of creating an RF wave, or rather amplifying an RF wave, but it also serves the same purpose. It also gives us the final output is again an RF wave. What we want is an RF wave. So in klystron, what happens is, again, you have a simple thermoionic emitter where you can emit electrons out. When the electrons are being emitted from this thermoionic emitter, they travel to this direction because of, again, positive charge, a net positive charge in this direction. So they travel. All these electrons are kept focused using a very strong magnet around it. So that magnet does not allow those electrons to repel one another, and they travel like a laser beam, like center, and they do not allow any electrons to turn around. And when these electrons are going along this direction, there are maybe multiple cavities, but in the base called the buncher cavity, and the other is called the catcher cavity. So the buncher cavity puts an alternating positive and negative voltage on these two walls. So what happens is, those electrons, obviously those electrons which are going in this direction, some of them are slow, some of them are very fast, but this buncher cavity kinds of creates an alternative electromagnetic field, electric field. So that electric field accelerates those electrons which are slow and dampens those electrons which are fast, because if this is suppose negative, those which have like passed and they reach here, they will be repelled because of this negative charge, and those which are like those which are slow, which left behind, they will be attracted by this wall, this positive wall. So this is how this buncher cavity kinds of create a uniform velocity of all those electrons instead of having a random velocities, different velocities. And then all those buncher cavities, like those buncher cavities, those electrons, when they have equal energies, they kind of accumulate here, and then there is a gap, and then there is another accumulation, like this keeps on going, and when they reach here again, because of their energy, they strike here, and then they create a same RF wave, same frequency RF wave, because they were oscillating here with a frequency, they were oscillating here with a given frequency, so they will travel, and then they will kind of oscillate here again and create an amplified RF wave. So the RF wave which was fed inside is now amplified. So you can think this as a drum, like when you beat the drum, you get a very amplified sound of the frequency that you are beating is now amplified because of that leather of the drum. The same way you feed in an RF wave, and that is being amplified using this other design. Obviously, only 35% of the electron can be converted, the energy of the electrons can be converted to RF wave. The rest 65% or 70% of the energy has to be collected here, and this heats up a lot. So you have to have cooling systems and several other mechanisms, engineering mechanisms. But the basic physics is you have a buncher cavity and then you have a catcher cavity. Because of the same frequency oscillation, this buncher cavity kind of bunches those electrons, and then the catcher cavities now oscillates with the electrons vibration, and that oscillation creates an amplified RF wave.